Good afternoon. My name is Sylvia Rondon. I'm an extension entomologist with Oregon State University. So you are in my state, okay? If you just take a car and you drive 3 hours east from Portland, you will be in our research station. It's the Hermison Ag Research and Extension Center. And it is the area of, our area of expertise is pretty much precision agriculture. And it's an irrigated area, basically. Completely different setup as the one you are here in Portland, completely different. Although if you stick around Thursday and Friday, it will be very similar because we're getting a lot of snow and rain. So I don't know if you like that, but I'm not ready for that yet. Today I'm going to be taking you from Central America to the Pacific Northwest again, and I will be talking about kind of our experience for the last 4 years regarding zebra chip disease, basically in the basin, kind of in the limit between Oregon and Washington. And although I'm speaking here, of course, I'm not working alone. I do have a large group of people in Oregon and also in other states that we have been working on this topic for the last 4 years. Maybe you recognize Phil Ham, his name there, well known in our area. He's our retired plant pathologist. We have Robert Kading, he's our diagnostician at the station. And there's a lot of collaborators also from the state of Oregon, extension agents, and also a large number of students and postdocs in my lab. And the data that I'm going to be sharing with you today is basically a lot of information that is coming from all these different people that you see here. And as you can see in the picture, this is early in the season, before they go to the field and they have to count thousands of samples. And I don't have a picture afterwards, but you can imagine what happened, right? So I think I have used this slide before, but basically, when you have a disease, like in this case, zebra chip disease, you need to have the vector, you have the pathogen, and you have the host. And when you do have these three things together, along with the right conditions, in this case, I'm mentioning only environmental conditions. This is what basically we had here in the basin back in 2011, when several of commercial fields were really severely affected by zebra chip disease. Of course, the people coming from Texas already had this issue way back from the early 2000s, right? But this was our first experience with zebra chip disease in our area back in 2011. And of course, it really got our attention because between Oregon, Washington, and Idaho, we do produce more than 56% of the potatoes in the United States. So you can imagine the concern of all the people involved in the potato industry. So basically, when this disease showed up here in the basin, in the Pacific Northwest actually, there were many unknowns. We didn't know how to deal with this issue. All the information was pretty much coming from Texas, great information, but we were not sure if this information would be applicable for our conditions here in the Pacific Northwest because it's completely different what you experience in Texas. In Texas, basically, you do have psyllids from the planting up to harvest, and in our case, based on our years of experience, we don't see those psyllids in the field until probably mid-June, and sometimes in early June. So we don't have to control them basically before that time period, while in Texas, you do have to control them since plant emergence. As we know now, great information coming from different labs, pretty much this disease affects all types of potatoes, varieties, and depending on what the potatoes go for the fresh market or cheapers, all are really greatly affected by this disease. And one of the issues that we have here in the basin is that we are still in, really this is a work in progress regarding training of the people that are checking, going to the field and checking if we have this issue or not. But if we only focus on the foliar symptoms of this disease, that was one of the first things that we really have to train ourselves, because in our area, of course, you know how can you see those purple tops and the scorching and so forth of the zebra chip disease in the foliage. But here in the Pacific Northwest, especially between Oregon and Washington, is really a hot area for another disease endemic from here, which is known as the beadleaf hopper transmitted diseases, BHTBA, transmitted by a beadleaf hopper here. And that was one of the first things that caught us by surprise. Before 2011, we were seeing all this purplish in the top of the potatoes, and when we took those samples to the lab and we were testing them for BLTVA, they were negative because we didn't know that we were dealing with a new disease in our area, okay? So obviously, we did put together a team, a group of experts from Oregon and other states, and we tried to develop an IPM program. And that's kind of what I want to share with you, some of the information that we have been collecting. And again, a lot of information is coming not only from my lab, also from the plant pathology lab and from other labs in the area. But basically, the first thing that we did was to start to detect this issue, how spread out was in the area. And another important issue was to determine if this insect, the vector, was able to survive in our area. We did some work haplotyping, but it was coming in a collaboration with, at that time, Jim Crossley lab and Kylie at the time. Some epidemiology work, some breeding, some control methods, economics, and technology transfer. My appointment is 75% extension, so my mission has always been to transfer that information to growers, okay? So from now on, what I'm going to concentrate is basically a lot of the applied results that we have been getting for the last several years. I would say one of the most first important findings for us here was to determine where the psyllids were coming from. Although it turns out that these insects, we had them all along. We have been checking and looking for these psyllids. They showed up even before the 2011 in our trap, okay? But one of the important things that was, besides not having potatoes, of course, in the winter months, where those psyllids were coming from. And apparently one of the answers, because as you will probably hear later, there's other alternative hosts for these potato psyllids in the winter, was this bittersweet nightshade, which is a Solanaceae wind, which really hosts large numbers of psyllids during the winter months, okay? So I would say that's probably one of the first important findings for our area. And again, here you see other weeds may host, and I don't want to steal the thunder from the other researchers who have found out other potential alternative hosts for these psyllids during the winter. This chart here is pretty clear. Basically, what we did is between probably mid-November until the following May of the following year, what we did is we started looking for places where we could find these bittersweet nightshades, okay? And the more we look for them, the more we find them. And pretty much is where a lot of the researchers go, that start paying attention of where they could find these bittersweet nightshades. And this is a perennial, and it's usually related to, you can find them next to water sources, canal sources, things like that. And if you go in the winter, it will be very hard for you to know that is bittersweet nightshade, because pretty much the foliage is dead. But if you go underneath of that dead mat, you will see that, and this is what we did. We went with some inverted leaf blowers, okay? We modified them, and we start sucking on those insects that were on those dead mats of bittersweet nightshades. And basically, during pretty much all winter long, we could find all the different instars of the potato psyllid in that bittersweet nightshade. So we thought that this was a really important finding. We took some data, of course, regarding temperature, and no matter how low the temperature is, still this insect can be found in that bittersweet nightshade. Sorry. The other important finding, and again, this was in collaboration with Jim Crossley at the time, Kylie, Joe Muyanesa, was the determination of the different haplotypes that we have in our area. Here, here on the right-hand side, you see the publication that Kylie put together back in 2013. And this is data that I pulled only from Oregon. But basically, what you can see here, that most of those psyllids that are found in bittersweet nightshades are basically the northwestern haplotype, meaning that the northwestern haplotype is the haplotype that it can be found during the winter months in our area. And the darker color are the western haplotypes, meaning that as season progresses, those western start moving into these areas, okay? There's some follow-up papers. This is just for the winter months, but there's some follow-up papers led by Kylie as well, where you can see some of how this information also translates into those commercial fields, where basically the majority of those seeds found in commercial fields are also from the northwestern haplotype. So we believe that this is excellent information. I mentioned, and I repeat again, that I'm an extension entomologist, so part of the work that I do pretty much season long, and specifically this reflects the things that we do during the growing season, is we have a very large sampling network where we not only look for potato psyllids, but we also look for other potato insects like aphids, tuber worms, which other ones do we look? 3 or 4 of those, and besides potato psyllids, of course. And all the ones, the purple dots that you see here, are the ones that my program runs, and the ones that are here on the upper basin and run by Kerry Wall from Washington State University. We pretty much communicate really well early in the season, and we have been doing this for many years, and we follow the same procedures basically. And at least in my site, I basically cover almost all Oregon except Ontario, which is the farther east of the state. And I have people in different areas, but basically I have one person who drives around 250 miles every Thursday, goes, puts the traps, collects them, brings them to my lab, and then I have another person in my lab that reads all the insects that were collected in those traps. And again, not only psyllids, but also other important potato pests. So basically, I think this information is well received by growers, because what this information tells you is basically, we know the GPS coordinates of each of those. I always encourage them that they have to put their own traps. But what they do is, once they see that in certain areas where they start picking up insects, they go and they start putting their own traps, even in larger numbers than ours, okay? And many times we do train them, their filmmen, so they will be looking exactly what they're supposed to be looking at, right? And what they do is, most of them, they share the information with us, and we are working on making pretty neat maps that hopefully I can share with you some other time. And we put them together in this newsletter that you see here on the right-hand side. It's the potato update. Andy Jensen also has another one that where he puts the link of ours, right? And basically what we do is during the, from April until October, late October, depending on funding, we email this information to growers with a table and the GPS coordinates of all our traps in a different location. And also on the other side, where we have been expanding this newsletter, we put any happenings in the area. And depending on if a grower brings us a sample that may be important for everybody, we share that information. Anonymous, of course, because we don't want to share those kind of details, how that works. While we were doing this statewide trapping, one of the things that really caught our attention was we listened a lot to growers. They were telling us, so Sylvia, you are telling us that here the potato psyllid only feeds and survives and reproduces on potatoes. Why are we seeing some potato psyllids in my corn, in my wheat? Of course, all those different crops are not related. And one of the answers was probably volunteers. And that's what one of my grad students, Matt, who's sitting there smiling, tell me if I'm doing well or not after I mention this. What we did is we come up with a design in the field, of course, in a small scale, where we planted, we had 5 different treatments. We have corn with volunteer potatoes. We have potatoes, of course, wheat and wheat plus volunteer. And this is just one graph summary of the entire season, okay? But of course, he did it weekly from planting till the end. But basically, what you can see from this graph is that, of course, this insect is very loyal to potatoes. But look at this one here, corn plus volunteer potatoes, and this wheat plus volunteer potatoes. There are some psyllids that are found there, and basically that's what that volunteer is doing. Is a source of those psyllids that are out there season long in those other crops. Okay, this is just data from 1 year. Matt is planning to repeat it the following year, but we found that this is really important because what it tells you is that control of volunteers may be an important issue when you want to diminish the number of potato psyllids out there. Since I'm on the chemical section and applied section, I want to share with you a few information about some of my chemical trials. I will say at least more than 45 to 50% of my programming has to do with working, doing a lot of chemical trials, and that's what I will be talking to you about in the next few minutes. This chart is basically a list of all those different products that growers are using in our area and how effective are against each different stage of the potato psyllid. And there's a lot of information about this, and there's not much time for me to talk about this, but if you are interested in knowing the results of our chemical trials, please give me your card or something, and I can share that information with you. But the other thing I wanted to mention to you is regarding those number of applications that growers in our area are doing targeting specific the potato psyllid. And this is a work that my previous postdoc, Eric Chegaray, is working on right now. And this is basically a summary of from 2012 and 2013 regarding different chemicals that growers are using right now in the field. We call the first treatment full, which is pretty much either 7 days or 14 days application of chemicals. And if you're going to ask me about which chemicals are, I can give you the name of those. We call reduced ones when there's 2 applications, half the number of applications that in the full one. And the control, of course, are all those fields when there's no chemicals applied against these potato psyllids. So this is kind of like a snapshot of what is going on right now in our area regarding chemical applications. What I can tell you between this one and this one is that both treatments do use something at planting. Okay, they are using Movento, at least 2 applications. They are using full field. And again, there's a long list, especially for the full insecticide regime that is mentioned in here. But the bottom line about these either full or reduced applications, and you can see here rotation 1, rotation 2, is that basically we get the same results if you are using a full insecticide program compared to a reduced one. Okay? And we're talking about, we were very careful selecting those fields where they had similar numbers of psyllids season long. The only thing that I want to mention here to draw your attention is in the number of psyllids, and here is on the y-axis. As you heard probably from Eric Wenninger early, after 2011, when the numbers were really high in the field, 2012 and 2013, the potato psyllid pressure in the area has been lower than that 2011 year. It doesn't mean that the psyllids are gone away, they just disappear from the area. It just means that we have less psyllids than before. So this is something that we always tend to forget. The insects are there, the issue is there. And I would say that this is the time where we should gather all the information needed in order to be prepared for any other outbreak in the future. I put on purpose this slide just to invite you to come to the Entomological Society of American annual meeting. It's going to be here in Portland, starts on Saturday and it's until Wednesday the following week. And I don't want to steal the thunder of Amber. Amber is one of my postdocs that is here. But one of the things that we are working on in my program is in alternative ways of controlling potato psyllids. One of them is through the use of thiamine. If you know about vitamins, thiamine is vitamin B1, sorry, I almost said B6, B1. And basically, there is a lot of information coming from other places in the world, in other crops, never used in potatoes. This is the first year that we tested this thiamine in the using potatoes as our main crop. But again, I don't have time to show that information to you, but we are summarizing the data. And another part that we're using also in my program is the study of plant growth regulators. That the philosophy is kind of similar as the project that you see above, and both talks will be presented at the ESA meeting. Just a few minutes, couple of minutes, 1 minute? Okay, sorry, I talked too much. I just want to show you 2 or 3 slides about the other piece of our work, which has to do with greenhouse studies. Since the natural pressure in the field was very low, what we decided was to do a lot of work in the greenhouse using artificial inoculations. Of course, we have colonies of hot with the bacteria and without the bacteria. And I will finish with this slide, and I will show you the data. Sorry, I talked too much. But basically, what we are doing for the last 3 years is doing some testing with artificial inoculations, testing the efficacy and residuality of different products that are either already in the market or they are about to be available for growers to use with some promising results. So I will stop here.